We will finish CSEC Multiple Choice Practice Paper 5 with Part D. Part D consists of the final 15 problems. These will take us from number 46 to number 60. A boat was traveling on a bearing of 270 degrees. In what direction is that boat traveling? This is a simple problem. That is, if you have the basic information on bearings. Let us take a look at some of the basics. A bearing is expressed by using 3 digits. Bearings are measured in a clockwise direction beginning at north. Bearings have 4 main directions. Let us take a look at the 4 directions and their associated angle. North associated with 000 degree. East 90 degrees. South 180 degrees. And west 270 degrees. According to what we have in the statement of the problem, we need the bearing associated with 270 degrees. That direction is given right here as west. West is 270 degrees. The correct answer is option A. The arrow diagram describes which relation? The arrow at the top is showing us that the values of x are being mapped to the values of y. Right here, x maps to y. This is in addition to the arrows that are within the relation. That emphasis is there to call our attention to the direction of the mapping. We have here, for every single case, an arrow that goes from an element in the set of x to an element in the set of y. The arrows that we have are indicating this. However, we have this additional arrow showing that all mappings are from x to y, which is just merely emphasizing that the relation is really mapping the values of x to the values of y. 2 is mapped to 8 and 10. Let us take a closer look at that. So we have 2 maps to 10 and 2 maps to 8. Also, we have 3 is mapped to 9, as we have it right there. We are just taking a closer look at it in this mapping that we have right here, which is basically taking what we have on this side and highlighting it right here. 4 is mapped to 8, as we have it right there. All we are doing right here is emphasizing the relationships that we have in this entire diagram. It is clear that each number that we have on the left, the values of x, is a factor of its counterpart on the right, the values of y. They are also smaller than their counterparts. Which option is correct? Now, all of these, as a matter of fact, are smaller than all of these. And we may even say that each one that we have here is smaller than the one that we have here. This one is smaller than this. Also, it is very clear that the numbers that we have here are factors of the ones that we have on this side. They are smaller and they are factors. X is a factor of Y is a possible description. Also, X is less than Y is one to be considered. Which one is correct? Option A is correct because in every case that X is a factor of Y, we have X mapping to Y. See, we have 2. 2 is a factor of 8. It is being mapped to 8. And 2 is a factor of 10. It is being mapped to 10. Also, 3 is a factor of 9, mapped to 9. And 4 is a factor of 8. It is being mapped to 8. So in every single case that X is a factor of Y, we have X being mapped to Y. However, each value of X is less than each value of Y. If the mapping indicated this, then every single value of X would have been mapped to every single value of Y. So, because this X is not being mapped to also 9 and 10, being less than 9 and 10, we are sure that this mapping is not indicating that X is less than Y. We do not have each value of X mapping to the values of Y that it is less than. Therefore, we are sure that X is less than Y is not the correct answer. Option A is correct, and A only. If f of x is equal to x squared minus x minus 1, then f of negative 5 is equal to... This problem requires that we evaluate a function f of x for a particular value of x. In order to solve this problem, one good initial move is to create a template that looks like the function. So there's your template that looks like the function. X is squared, therefore we leave a slot for it. So where we have x squared, we have something squared. There we have minus x. Next, we need to subtract x. The slot is also made available for it. Let us insert the values of x equals negative 5 into each slot. So we will have f of negative 5 is equal to negative 5 squared minus negative 5 minus 1. The square of any number is positive. The square of negative 5 is therefore positive 25. The negative of a negative number is positive. We may also treat it the same as the multiplication of a number by negative 1. So we have negative 5 may be treated as negative 1 multiplied by negative 5. But of course, without treating it like that, we are sure that when we have consecutive signs, two consecutive signs that are like, we replace them with one single positive sign. So we have a positive 5 right there. Finally, we need to include that negative 1 that we have right there. 25 plus 5 is 30 minus 1 is 29. The correct answer is option B, 29. By using the template, there are a few errors that may be trapped and eliminated. -5 is placed in the brackets and squared. This demonstrates that the entire -5 is squared and not only the 5. There is a negative sign preceding the second brackets. When -5 is inserted, the double negative is clearly seen. In haste, a candidate may just use a single negative sign. It is not impossible to solve the problem without a template and get it right. The inclusion of the template just makes it more likely. So we have a -5 here. The entire -5 has to be squared. A possible error would be just to square the 5 alone. If we square the 5 alone, we would have received at -25. Also, right here, because we are inserting -5, a candidate may just be tempted to have a single negative sign. And then we have a -1. So, the answer would have been -25 minus 5, that is -30, minus 1, -31. And we have the distractor right here in option A. Therefore, it is important that we attempt such a problem by including a template. Also, it is not a complete necessity, but it reduces the likelihood of making a mistake. Which of the following relations is a function? It is not often that we see relations expressed with the arrows going from right to left. This should not prevent us from solving the problem. The principles are the same. All this means is that the domain is on the right and the codomain is on the left. Besides, we are accustomed to qualifying a relation as a function that has an inverse, which requires the ability to assess the reverse mapping even without the arrows going in the reverse direction, and is actually more difficult than what is required of this problem. Therefore, we should have no difficulty arriving at the correct answer. 1. We are accustomed to qualifying functions as those that have inverses, which requires that we are able to see in the direction that is opposite to the direction in which the arrows are going. I think that is a little bit more difficult than what we have here. Therefore, we have a problem that is not as difficult as the most difficult problem that we have faced in assessing relations and functions. A, B, and C are not functions because 2 in A and C and 3 in B are mapped to more than one element. So we have 2 is being mapped to B and C. Here we have 3 mapped to B and C. We have 2 mapped to A and B. Therefore, these are not functions. Of course, we are not considering the mapping as from left to right. We are considering the mapping according to the direction of the arrows. So all of those are out. The only one that we have left is option D. It is the correct one. A and C are not functions for an additional reason. In options A and C, there is an element in each domain that does not have an image. They are out on 2 counts. Sin has been added to sin. So we are sure that A and C are total impossibilities because we have 2 situations in which we may be able to identify that A and C are not function. We have 3 that does not have an image that is in the domain, and we have 1 in the domain of C that does not have an image. We are sure that these 2 are not functions on top of what we had before. A function is a mapping from one set called the domain to another set called the codomain in such a way that each element in the first can have only one image in the second. 2 has 2 images, so we are sure that this mapping is not a function. And we say the same thing for the other mappings. The only mapping that satisfies the requirement is option D. That is, the requirement of being a function is option D. We need to determine the median of the set of numbers that we have right there. The median is the middle entry in an ordered list. One may be a bit hasty because of how simple the problem is and find the middle entry in the list without sorting it. However, the problem is organized that on this occasion the list has to be ordered first in order that the middle entry is actually the median. This one is not sorted. We therefore need to sort this list in order that the median will be the middle entry. Let us go straight ahead and order the list. 1 goes first. The next number in numerical order is 5. We have 3 occurrences of 5. Next we have 8, and in numerical order immediately following we have 9. No 10. We include 11, and the list is ordered. There are 7 entries. The middle entry will be the 4th. 7 divided by 2 is 3.5. We are sure that the middle entry is the 4th. We could have used the primitive method of simultaneously striking off entries at the end until only 1 entry is left. So those 2 will go, and we are going towards the middle, and we take the next in line. Finally, we have only 5 left, and that is our median. The median is 5, and the correct answer is option A. Ordering the list does not require a shuffling. If sorting can be done mentally, there is no rule against it, especially that all that is required is the correct answer. A ship sailed 8 kilometers due east from A to B. It then sailed 6 kilometers due north to C. Which diagram below best represents the path of the ship? Let us begin by including a chart as a reminder of the cardinal direction, and we have it right here. North, east, south, west. And we are a little bit previous, saying that D is the correct answer. Why is it that A is not the correct answer? Let us take a look at it. There we have A. We are going from A to B. A ship sailed 8 kilometers due east. Therefore, from A we will go in the direction of east to B, that direction. Right, there we have B. And we have 8 kilometers. So we have A to B in an eastward direction, and the distance covered is 8 kilometers. What about the other one? Right, 6 kilometers due north to C. North, that direction. So we go north to C. Six kilometers. There, it is shaping up to be like D. But isn't it like A also? Option C is for someone who believes that in case of emergency, choose C. There is no way that it can be correct. So there is no way C can be correct, because the ship cannot leave from A to B, and while at B, it is leaving from A to C. That's a total impossibility. Therefore, I'm saying that option C is there for someone who believes that in the case of emergency, just choose C. That's a little tip that some students use when solving multiple choice problems. Option B is for someone who has the directions nicely mixed up. At first glance, option A appears to be correct. Only the distances are incorrect. If one does not pay attention to details, he may mistakenly choose A. The correct answer is option D. The relative lengths of the line in D are also correct. However, there is no need to worry about that because the diagrams are not usually drawn to scale. So A kind of look like it. So we have A to B to C, and we have A to B to C. However, the 6 kilometers is first here and the 8 kilometers second. That may be placed there in order that it may be a distractor to a candidate who is basically going on a speed and is unwilling at that particular stage of the game to pay attention to details. We have it as number 51. Therefore, time should be running out and the candidate should be moving faster than Usain Bolt. Which of the following sets represents the relation f such that x maps to x squared plus 3? Is it that? Well, let's see what that highlighter mark is placed there for. The content of each pair of brackets is called an ordered pair. So we have an ordered pair right there, and we are highlighting an ordered pair. An ordered pair is the contents of a single pair of brackets. Like this. That's an ordered pair. What do we have there now? The entire set is called a set of ordered pairs. So there we have an entire set of ordered pairs. For clarification, we have expressed each ordered pair as a mapping. Just for clarification, just so that the candidate may be able to understand why we have the functions expressed in this manner. Let us just take a look at one of them. We have in A, 0 maps to 3, so we have it 0, 3. We have 1, 4, an ordered pair means that 1 is being mapped to 4. 2, 7 means 2 is mapped to 7. 3, 12 means that 3 is mapped to 12, and so on. So I think that is good enough to clarify the significance of the ordered pairs. In all of the options, all of the first numbers are the same. Notice that we have 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and so on. So we see that in all of the options, all of the first numbers are the same. This is because they represent mappings in which the domain, which is the set of first number, is the same in all cases. Okay? So all of these numbers, the first numbers, are the same in every single case because in every single case the domain is the same. That is why we have all of them being equal. The domain is the same in every single case. In an examination, I imagine that the examiners will consider it unfair for a candidate to examine all 16 pairs in order to determine the correct answer. This will take too long. The most logical answer is therefore option A. Option A is the most logical answer because there we have a nicely mixed up, what would I say, meal of numbers all over the place. I'm just saying that it might be that the examiners would not want us to check through every single one of them. So the examiner might want to be fair and cause option A to be the correct answer. In an examination, time is of the essence. The examiners know this, and they might not want us to waste too much time on a single problem. If we can solve it, they will not want us to spend an entire half an hour just on this problem alone. So indicate that option A is correct. All the candidate needs to do is just check. We think all the candidates need to do is just check. 0 squared plus 3 is equal to 3. 1 squared is 1 plus 3 is equal to 4. 2 squared is 4 plus 3 is equal to 7, and so on. And as soon as that is done, then the candidate will not need to check the others. So maybe the examiners are being considerate, and option A may be the one to demonstrate how considerate they are. So let us say option A is correct, and if it's not, then we will see on the next slide. However, choosing an answer for the reason mentioned on the previous slide is just not valid. It is not valid to imagine that the examiners will not want us to waste too much time and indicate that option A is correct, in order that as soon as we check the first one, we see that it is correct and we move merrily to number 53. That is not a valid enough reason. By examining all of the answers, that is, the second numbers, we realize that in option A, 12 is the unique result of the fourth pair. So we have 12, the unique result of the fourth pair. Well, I wouldn't say the unique result. I would just say a unique result, because we have 6 that is also unique. So we say 12 is a unique result. 6 is also a unique one. But because of the uniqueness of 12, we will move merrily and examine that. If we substitute 3 into the expression and the result is 12, then we have solved the problem by examining only one pair. So we have f of 3, 3 squared plus 3, that is equal to 12. 9 plus 3, that is equal to 12. Therefore, the problem is solved. We have identified the correct answer as option A. There we have shown that the correct answer is actually option A, just by making only one of 16 possible examinations. And I'm sure that for quite a few candidates looking on this problem, I'm sure that candidates may be thinking it is impossible just to look at one pair and solve the problem that involves so many pairs. But I'm saying that it is a possibility. The first method is not ideal, but in the event that any such problem appears when you have only 1 second left, it may result in you obtaining an extra mark. So some students will just have, like at the end of the examination, a single second, and we see a very cumbersome problem. We just choose A. Well, it is better than choosing nothing at all. Turns out that it is the correct answer. If you did not choose it, then you would have missed out on possibly the single mark that will push you over to the distinction side. Although it is not an ideal or even a valid method, in multiple choice examinations, common sense and pure techniques might help you to get a few marks in the event or in the case when you would otherwise not get any. Let us say 12 failed to prove that option A is correct. We know what we had to do if it fails to prove that option A is correct. So let us say that 12 failed to prove that option A is correct. Further, let us assume that the result is actually 9. Since there are 2 pairs that result in 9, we would have to check another pair in one or both of the relevant options in order to be guaranteed an identification of the correct answer. So if 9, let us say that 9 gave the correct answer, then since we have 2 of them, we still would not be sure which option is correct. We will have to go then and probably check another pair. We could probably check this pair or this pair. Definitely we would not choose this pair because we have 3 and 3 right here, and because the answers are the same, one is not distinguished from the other. So if 9 were correct, we would have to choose some other pair and examine them. In any event, we realize that the correct answer may be identified by making very few of the possible calculations. So if 9 were correct, we would have to take another go. So we could have done that in 2 comparisons. Using the correct technique then means that it will not take us too much time and too many comparisons in order to identify the correct answer anyway. Let us examine the reason why a single unique result may guarantee the correct answer. That we will do. We are going to take a look and see how just by making one calculation we are able to identify the correct answer. 12 is not the only unique one in the 4th answers. So we have 12 is not the only unique one. 6 is also unique. If it were not correct on calculation, then we would have to consider the other unique one, which is 6. Why are we going for the unique ones? Because if we choose 9, we have 9 here and 9 there. If 9 is correct, then we also have to consider the pairs in these options. The fact that 12 is correct eliminates all others as the correct answer. How so? Since two answers cannot be correct unless they are equal. Right. Two answers cannot be correct unless they are equal. We are sure that 12 is correct. Therefore, since 12 is correct and it is not equal to all of these, we are sure that the only correct option is A. And that's all there is to it. We did not choose to ignore 9 because it is impossible for it to be correct. That was done because if 9 were correct, we would have to check another pair because 9 is not unique. We ignore 9 because it is not unique. If it turned out that 9 is correct, we would have to choose something else. So we chose to ignore it because if it were correct, we would have to check another pair. So we choose to examine 12 because it is unique. And if it is correct, it would have eliminated every single other option as being correct. We are using a process of elimination in which we need to forsake all possible incorrect answers as quickly as possible. So we are ignoring every single one that has a chance of being incorrect. Those are the ones that we are ignoring. We cannot have two answers being correct if they are different. We cannot have two answers being correct unless they are the same. Therefore, we choose one that is different in order to eliminate the possible incorrect answers as quickly as possible. At the other extreme, we needed not examine the first ordered pairs. The results, which are the second numbers, are all the same. There is no way those could have been used to distinguish one answer from the other. So these could not have been used to distinguish one answer from the other because they are all the same. Therefore, we did not choose to examine this. Therefore, it would be more appropriate to examine numbers that are unique. The biggest question is, suppose 12 is correct, but other ordered pairs in that same option do not conform to the result. That's a big question. Let us say that X is correct. But when we choose, like this one, it is not correct. How would we deal with such a situation? If this is the case, there would not be any correct answers. Option A would have been incorrect, and the results of the fourth pair in the other options are all incorrect. If, after seeing that 12 is correct, we examined this one and it is not correct, what would we do? Well, I'm saying it is impossible after 12 being correct to examine this and it is incorrect, because since 12 is correct and these are not equal to 12, all of these are incorrect. Therefore, if we have this being incorrect, then we'll have all of these being incorrect and this option being incorrect, and we would not have any correct answer. If A, B, and C are constants, the equation of the graph could be, which one of these options? The statement of the problem is one word short, I think. In my opinion, the statement of the problem is one word short. Instead of constants, we should have had positive constant. This is because a positive constant accompanied by a negative sign gives a negative result, and accompanied by a positive sign will give a positive result. If we do not know the sign of the constant, we will not know the sign of the result. So we need to fix the constant as being positive. We could fix it as being negative, but I think fixing it as being positive is the best way to express the problem. Because if we have a positive constant, say A is positive, and we have a negative sign here, then the entire part would have been negative, and we have this negative sign here. I think that would be more true to what we have right there. So if we have all constants being positive, anywhere we see a negative sign, we know that it implies a negative result. And if we have a positive constant right here, where we see a positive sign, we know that we have a positive result. So I think that stating that the constants are all positive will cause the statement of the problem to be more sober for that particular reason. And as we solve the problem, we will see possibly other reasons. However, we may safely assume that the intention of the examiner is that we take all of the constants as positive. All things will be exactly as they appear. So, although it was not said that the constants are positive, we are assuming that the examiners intend us to consider that the constants are positive. But let us see what will be the result of that. Options B and C are out of the question, because in the equation of a parabola, if the x squared coefficient is negative, the curve will have an umbrella shape. The umbrella shape like this way. So if the x squared coefficient is negative, the curve will have an umbrella shape. And then we have it right here. X squared right here accompanied by a negative coefficient. And we have it right here also, a negative coefficient. In that event, the curve will have an umbrella shape, opposite to what we have here that we call a U shape. If the x squared coefficient is negative, the curve will have an umbrella shape, which is not the one that we have here. The curve is U-shaped. Therefore, in the equation, the coefficient of x squared has to be positive. The curve is U-shaped. A U-shaped curve has x squared coefficient being positive, like what we have here and there. Umbrella shape has negative x squared coefficients. These are out because the curve is not umbrella shaped. So options B and C are out. We are saying that option D is correct. The correct answer is option D. We have no coefficient of x in option A. If C is positive, notice that we do not have a bx here. We just have ax squared and c. No bx. We have no coefficient of x in option A. If C is positive, as we assumed previously, that curve will not cross the x-axis. If it is negative, contrary to what we have assumed, the curve would have crossed the x-axis at equal distance on opposite sides of the y-axis. Let us take a look at the reason why, if C is positive, the curve will not cross the x-axis. At each point on the x-axis, the value of y is equal to 0. That is our premise, that everywhere, we are sure that everywhere on the x-axis, y is equal to 0. And as a matter of fact, that is the reason why the equation of the x-axis is y is equal to 0. X squared plus 9 is equal to 0. That is, when we consider that c is positive. Here we have made the coefficient of x squared equal to 1. C has a positive value. The expression is equated to 0 because y is equal to 0 on the x-axis, as we have discussed before. So we are saying x squared plus 9 is equal to 0. We are inserting here in the place of c a positive 9. And we are saying that the coefficient of x squared, the value of a, is equal to 1. We have 1x squared, or just x squared. A sum of squares does not have any real factors. The equation will not have any solution. Therefore, the curve will not cross the x-axis. We may make our point clearer by transposing the constant to the right-hand side. So we say x squared plus 9 is equal to 0. We are saying that a sum of squares cannot be factorized to give real factors. We are eliminating completely the possibility of factorization, but we are attempting to make our point clearer by transposing with this positive 9 right here. We have x squared is equal to negative 9. In order to find the values of x, we will have to find the square root of negative 9. So x squared is equal to negative 9. X is equal to the square root of negative 9. Check your calculator. Find the square root of a negative 9. Well, you do not imagine that you will have a calculator in a multiple choice examination, but we are taking a look at the principles that we may consider in solving a particular problem. The square root of a negative number does not exist. As you will see, it will give a fatal error on your calculator. The x-intercepts will not exist, and the curve will not cross the x-axis. So, right here, we have two possibilities. One, when x squared plus c, and c is a positive number. If c is a positive number, the curve will not cross the x-axis, but this curve crosses the x-axis. Therefore, we are sure that a is not correct. But let's see what will happen if it is a negative number. What about if in option A the constant were negative, contrary to our early assumption? Our early assumption is that c is positive. All constants are positive. But let us say then, we are just assuming, but the examiners may intend that we be more flexible. And it is possible that c can be negative. So we have x squared minus 9 is equal to 0. This is a difference of 2 squares. The expression is a difference of 2 squares that we know to have real factors and may be factorized. Like so. X plus 3, x minus 3. These are the factors of x squared minus 9. And the solution we may have as x is equal to a positive or negative 3. The values of x obtained are negative and positive 3. They are equal distance from the x-axis on either side. That is what we expect if the constant c is negative and there is no x value. Like in this particular case, c is negative and we do not have any bx. Right. Therefore, we are sure that for A, this option is impossible to be correct, because if C is positive, the curve will not cross the x-axis. And if it is negative, it will cross the x-axis on either side of the y-axis and equal distance from the y-axis. X squared minus 9 is equal to 0. The equation could have been solved by transposing 9. No problem seeing a negative 9 being transposed a positive 9. Then we have the square root of 9. And the square root of 9 is a positive 3 or a negative 3. It would have still been possible to determine that we could have received two values of x. The square root of 9 is a positive 3 for obvious reasons. Negative 3 is also a square root of 9 because multiplying negative 3 by itself results in a positive 9, since negative multiplied by negative is equal to positive. So we have, obviously, positive 3 is a square root of 9. Also, we have negative 3. If we square that, we will have negative 3 multiplied by negative 3. Negative multiplied by negative is positive. The circumstances would have been the same even if the constants were not a square number, like we have 8 to find the square root of 8. If it were not a square number, the values of x obtained would have been irrational. That is, they would have been square roots with decimals that have an infinite number of decimal places. However, they would have still been equal but of opposite signs and appear at equal distance on opposite sides of the x-axis. So, let's say that we have as we said before, minus 8. Then we'll have what? X is equal to the square root of 8. The square root of 8 does not have a finite decimal representation. Therefore, we may think that it's a little bit awkward. It is not. The principle will be the same. The two x-intercepts will be equal distance from the y-axis on either side of the y-axis. A flaw exists in the problem because let us take a look at what would have happened if all of the constants were positive. Let us say that all of the constants were positive, like in that particular case. X squared plus 6x plus 8 is equal to 0. Let us solve the problem by factorization. Of course, we can factorize that. Two numbers multiply to give 8 and add to give 6. 2 and 4. 2 4 is 8. 2 plus 4 is equal to 6. The factors are x plus 2, x plus 4, and the answers will turn out to be, when we finish up the solution of that quadratic equation, x is equal to negative 2 and x is equal to negative 4. If all of the constants were positive, the two values of x obtained would have been negative. The two x-intercepts would have ended up on the negative side of the x-axis. Option D could not have been a possible representation of the curve. So if all of the constants were positive, then we would have a serious problem, because if that were the case, both intercepts would have been on this side of the x-axis, on the negative side. One may say now, or be critical of Rita James' mathematics resources and say, you are the one to be blamed. You are the one who are saying that the constants should be positive. But the statement of the problem did not say that. But what is the drawback in not saying that? If we want to play it safe and cause the constants to be what we want them to be, the coefficient of x squared will be affected and the curve could have been either U or umbrella shaped. So by flexing a bit with the sign of the constants, then we would not or cannot be sure of whether the curve would be U-shaped or umbrella shaped. Therefore, we need to fix the sign of the constants, because if we do not do that, then we have a serious problem with the shape of the curve. The safest route out would have been to include in the statement of the problem that all constants are positive, and to use a curve with both x-intercepts on the negative side of the x-axis. So stating that all constants are positive will give us an idea that the curve must be either U-shaped or umbrella shaped. That would have been fixed by saying that the constant is positive. However, if all constants are positive, the curve that we have here should have been placed on the other side of the x-axis, and that would have caused the problem to be, well, if it is not going to be perfect, then it is going to be correct to principle. With center A, an arc BC is drawn. With center A, BC is drawn. With center B and the same radius, the arc PCQ is drawn. With center B and the same radius, PCQ is drawn. What is the size of the angle BAC? BAC. What is the size of the angle BAC? Every student who is familiar with construction knows that what we have is the construct of a 60 degrees angle. The correct answer is option C. As soon as you see this, you know about construction, you have no doubt that what we have there is the construction of a 60 degrees angle. Option C is correct. That's all there is to it. The construction of a 60 degrees angle is based on the fact that the sum of all angles in a triangle is 180 degrees. If we can draw a triangle with all angles equal, in which case all sides have to be equal, then each angle will be equal to 60 degrees. We will have created an equilateral triangle in which all of the angles are equal. All sides are equal, all angles are equal. We have each angle will be 180 divided by 3, and that will give us 60 degrees. So that is the premise on which we construct a 60 degrees angle. The first arc BC was drawn with center A. There we have the arc BC. It was drawn with center A, but we are highlighting these two. Why? Because this means that AC and BC are radii of the, and we say potential, of the potential circle. They are therefore equal in length. Therefore, we are drawing a circle with the center is A, and we go like this. We are sure that the distance from here to here is equal to the distance from here to here. Why? Because these distances will be radii of the circle. with center B and the same radius, the arc PCQ is drawn. But we are highlighting same radius. Same radius. What does that mean? That means that whatever we are about to do, because the radius is the same, we are sure that these radii are equal already. The next radius is the same. So we are going to draw this arc PCQ that will complete a trio in which all sides are equal. So that is our triangle with all sides equal. First, this arc causes this and this to be equal, being radii of the same circle. And it is saying same radius with the same radius. We are drawing this arc. That means all of the radii are equal, and we are sure that all sides are equal. We have an equilateral triangle, and all angles are equal. Since all angles are equal, each one is equal to 60 degrees. All of the sides are equal. All of the angles are therefore equal. Each one is equal to 60 degrees, and we are sure that the construct is that of a 60 degrees angle. The sum of the interior angles of a polygon is 4 right angles. Then the polygon is a triangle, hexagon, pentagon, quadrilateral. Let's see. 4 right angles. 4 right angles in the statement of the problem serves as a kind of giveaway. As soon as that phrase is encountered, the first thing that comes to mind is a quadrilateral. We naturally associate 4 right angles with squares and rectangles. The correct answer is option D, quadrilateral. One may not be too concerned that the statement of the problem is in no way indicating that each angle of the polygon is equal to a right angle, but that their sum is equal to 4 right angles. In the end, that would not have been a determining factor. Does not prevent option D from being correct. So as soon as we see 4 right angles, we associate that with squares and rectangles. So we are quick to say that quadrilateral is correct. However, by saying it is equal to 4 right angles, that is, the sum is equal to 4 right angles, the statement of the problem is no way indicating that each angle of the polygon is a right angle. But in the end, that would not turn out to be a determining factor. It is also true that 4 right angles are equal to 360 degrees, a right angle being equal to 90 degrees. So 90 multiplied by 4, 360 degrees. We know of old that the sum of the interior angles of a quadrilateral is equal to 360 degrees. But if this will not suffice, we will go to the next slide and make calculations in order to put the certainty of it beyond the shadow of a doubt. So we know that the sum of the angles in a quadrilateral must be 360 degrees. However, if that is not enough for option D to be selected, let us move to the next slide. We may take the formula for the sum of the interior angles of any polygon. What is that formula? 180 degrees multiplied by n minus 2, that is equal to the sum of all of the angles in a quadrilateral. There we have 4 right angles. We are assuming that we do not know the number of sides that the polygon has. What we do know is that the total internal angles is equal to 4 right angles. We do not know what the number of sides is, but we are sure. What we do know is that the total internal angles is equal to 4 right angles. So let us use that formula. 4 right angles. Each right angle is 90 degrees. Expand the brackets on the left hand side and multiply the numbers on the right hand side. So we have 180 times n, 180 n, and 180 multiplied by -2, -360. 180n minus 360 is equal to 360, because 4 multiplied by 90, 4 right angles, 360 degrees. Adding 360 to both sides will result in -360 being eliminated from the left hand side, and 360 will be added to the right hand side. So we have 180n. This is eliminated. Added to the right hand side, we have 270. Dividing both sides by 180 will result in 180 being eliminated from the left hand side, and on the right hand side, 720 divided by 180 is equal to 4. N is equal to 4. Any figure that has 4 sides will be a quadrilateral. A 4-sided figure is a quadrilateral. That is all there is to it. A rectangle has rotation symmetry of order 1, 2, 3, or 4, which is correct. The order of rotational symmetry tells us the number of different positions in which an object may be placed and will appear to be exactly the same. That is, if it is rotated about its geometrical center. We may make use of a mental picture in order to determine that the order of rotational symmetry of a rectangle is actually 2, or we may do it from memory. Sometimes we may be able to do the rotation in our minds, or sometimes we just know that the order of rotational symmetry of a rectangle is 2. We may also perform the actual rotation and see if there is any other position in which it may appear to be exactly the same as it was before. We may also determine, if any other, the number of those positions. So let us actually do the rotation. Notice that we are a quarter away around there, and now we are halfway around there. We have not completed a full 360 degrees, in which event we would have been at the same place that we have started. We are only halfway around. See, there is just a quarter of the way around, and we have a half of the way around, and we realize that the rectangle is exactly as it was before. So we are sure that it is in the original position as we have it right there, and if we turn it, it will appear to be exactly the same halfway around. So we have 2 positions. So far, the rectangle has 2 identical positions: the original one and the one that is half of a full revolution. It therefore has rotational symmetry of order 2. The correct answer is option B. In each of the diagrams, A prime is the image of A. Which of the diagrams shows a reflection in the x-axis? Which of the diagram shows a reflection in the x-axis? The correct answer is option A, because we can see that the x-axis divides the single figure formed by the object and its image into halves that are mirror images of each other. So we have right here that there's a single object formed by the original object and its image, and x, the x-axis, divides that object into two halves that are mirror images of each other. It is also a requirement that the object and its image is on either side of the mirror line, and that we have here the object and its image on either side of the mirror line. The mirror line is x. The object and its image are on opposite sides of the x-axis, and the x-axis divides them into halves that are mirror images of each other. We are sure that option A is correct. The mirror line is the x-axis. Let us highlight the x-axis in every case. So we have the x-axis, and we are highlighting the x-axis in every case. In a reflection, the line joining a point to its image is perpendicular to the mirror line. In each diagram, let us use a line to join the point to its image. Alright, that is what we have done right here. A is joined to A prime is joined to A is joined to A prime, A is joined to A prime. That line should be perpendicular to the mirror line. Now we have the mirror line in every single case, which is the mirror line is the x-axis. There we have the mirror line, the x-axis in every single case. Notice that what we have there, right here, we have the line joining the point to its image. Notice that only in the first case, that is the option A, that the line joining a point to its image is perpendicular to the mirror line. So this one is not perpendicular to the mirror line. This one is actually parallel to the mirror line. This one is not perpendicular to the mirror line. Only in the first case, the line joining a point to its image is perpendicular to the mirror line. For the setup that we have to be a reflection, the line joining a point to its image must be perpendicular to the mirror line. For us to conclude that we have a reflection, a point and its image is equal distance from the mirror line. The second property needs no investigation because none of the other options met the first criterion. So we have two criteria for reflection. The point and its image must be equal distance from the mirror line, and the line joining a point to its image must be perpendicular to the mirror line. We have a single case in which the line joining a point to its image is perpendicular to the mirror line. This one is correct. We do not have to go to the second one to say that they need to be equal distance from the mirror line. Why? Because in no other case the first criterion was met. In the right angled triangle, which trigonometric ratio is equal to 4/8? So which trig ratio is 4/8? In the diagram, one of the short sides of the triangle is not known. This eliminates the options that make use of tangent. So this is missing. Because it is missing, we know that tangent is not a possibility, because tangent of x is opposite over adjacent and tangent of y is opposite over adjacent. This one is missing. Tangent cannot be correct. The only ratios that are left contain x. Names of the sides of the triangle must therefore be relative to x, because in the other options we have cos x, sin x. That means the names of the sides of the triangle must be given relative to x. That means the sides of the triangle must be given names relative to x. We have the hypotenuse. It's always the longest side, not relative to x. So the longest side is called the hypotenuse. It is opposite to the right angle. The side that is on the other side of, facing or opposite to the specified angle is called the opposite. The side that is beside, alongside or adjacent to the angle is called the adjacent. We have 4 over 8. 4 over 8. 4 is the opposite and 8 is the hypotenuse. We have 4 over 8 is equal to opposite over hypotenuse. The ratio in the statement of the problem is 4 over 8. In the given triangle, this is represented by opposite over hypotenuse, as we have it right there. And opposite over hypotenuse is equal to sine of x. Opposite over hypotenuse is sine. The correct answer is option C. Irrespective of which angle is involved, the tangent trig ratio always make use of the two short sides of a right angled triangle. Since one of the short sides is missing, there is no possibility of tangent in the correct answer. So tangent always make use of the two short sides of a right angled triangle. If one of the short sides is missing, then we are sure that tangent is not applicable. How many triangles congruent to the triangle AED would be needed to cover this square ABCD? How many triangles congruent to AED, this one? How many triangles congruent to this one is needed to cover the entire square that we have right there? Probably the most significant word in the statement of the problem is congruent. Congruence means the same in all respects. For geometric shapes, they have all sides and angles equal. That is what congruence means. That means if we have two triangles that are congruent to each other, they have corresponding sides equal. So we can find side 1 equal length to side 1 on the other one, side 2 equal length to side 2 on the other one, and so on. Also, we have corresponding angles. Angle A is equal to angle A in the other one, and so on. The question really requires the number of triangles that are identical to AED that will cover the square ABCD. The meaning of the word congruent is enough for some candidate to just look at the diagram and determine that the number of triangles is equal to 6. Right? No problem doing that very quickly. Option C is correct. However, let us demonstrate this by taking AED and replicate it as many times as necessary to cover the square ABCD. So we will take the AED right there and replicate it as many times as it is necessary to cover the square ABCD. And notice that we have how many times? We have 6 times. We have 6 of them. Congruence does not require that the shapes are arranged in exactly the same way, only that they have corresponding angles and corresponding sides. They may be upside down or laterally inverted, and so on. So we do not have to have them looking like this, 1, 3, 5, for them to be congruent. As long as we have that this side here is equal to this one, and this one is equal to this one, and they both have corresponding hypotenuse, then we are good, irrespective of how they are arranged. ABC is a triangle in which AD is equal to BD is equal to CD. Angle ABC, we need to find angle ABC, which is this one. And this is the situation that we have right here. ABC, find this angle if all of these sides are equal. Notice what we have there is that what? The marks that we have here are telling us the sides that are equal, and we also have that in the statement of the problem. Those marks indicate that the length of the line segments are equal. The statement of the problem also declares it. This causes the two smaller triangles to be isosceles. So we have an isosceles triangle on this side and an isosceles triangle on this side, because we know that this is equal to this. These two sides are equal. We have an isosceles triangle here and an isosceles triangle over here. In the first isosceles triangle, the two equal angles will be called x in the first one. So we have the two equal angles in this one, and we call them x. These are the two equal angles. The other one, which is this one, that does not play too much part in the rest of the problem, is the rest of 180 degrees. So we will have this angle is 180 degrees minus x minus x. It will be 180 degrees minus 2x. So we have x, 180 degrees minus x. In the second triangle, the equal angles will be called y. So we have y and y. Those are equal, and the other angle will be the rest of 180 degrees. 180 degrees minus 2y. Focusing on the big triangle, all of its angles will add to give 180 degrees. Big triangle, all of the angles will add to give 180 degrees, like in any other triangle. So all of those will add to give 180 degrees. When we add them, we have x plus y plus y. When we put them together, what do we get? We get x plus x is 2x, and y plus y is 2y. So we have 2x plus 2y, and that is equal to 180 degrees. Divide the entire equation by 2. So we can have x plus y. Divide the entire equation by 2. That is acceptable. Dividing or multiplying an equation by a single number does not change its value. So we have 2x divided by 2, 2y divided by 2, and 180 divided by 2. This angle here is x plus y. We have x plus y is equal to 90 degrees. The angle ABC is the sum of x and y. The correct answer is therefore option B, 90 degrees. So we have x plus y in the end, according to our equation here, is equal to 90 degrees. And that is what x plus y turns out to be in the end, which is, of course, this angle. So the angle ABC turns out to be 90 degrees.